Okay, today's lesson is 7-3. So if you open your book to page 460, you'll see 7-3 multiplication properties of exponents. So if you can get your vocab sheet out, we're talking about right here simplifying exponential expressions. If you look on page 460, you'll see a big yellow know it box that talks about how you know if an expression is simplified. And a lot of these rules aren't going to make sense to you right now because you haven't learned all of the steps, but I'd like you still to take some notes on them. So, expression is simplified if there's no negative exponents. So that's definitely one you know. We did that yesterday. You have to completely remove negative exponents by moving them either to the numerator or the denominator. The second is that the same base of a power isn't repeated. Because if that same base is repeated, that means that you had other multiplying or dividing that could have been done. You can't have any powers of powers, and you'll understand after today's lesson what a power of a power means. And anytime you've got coefficients that are fractional coefficients, you have to make sure those are reduced. So those are just a couple of the rules. If you'll take a minute to copy down the examples and the non-examples. So here's 3 examples of simplified expressions. Notice that there are no negative exponents. The bases of a and b are not repeated. And the fractional coefficients are reduced. So here's some non-examples. And I'll talk to you about what is the problem with each of these. But in this first one, the problem is that you cannot have a negative exponent. So that's the problem. Here the problem is that the base of x is repeated. X times x squared. That we can simplify. Here's an example of a power of a power. We're raising z to the 3rd power to the 4th power, so a power of a power. That's not simplified. And this one's not simplified because we have what's called a product of a power. A product means we're multiplying 2 things and they're all being raised to the power. So those are things we're going to learn today that can be simplified. Okay, so if you have to pause the video and take a minute to record those, please do that. Now we're going to go on to 2 other rules. So the first rule for today is called the product of powers property. The product, meaning multiplying, of powers. So we have 2 powers that are being multiplied. And notice that in this example they both have the same base of a. So the rule is that the base stays the same and you add the exponents together. So if you look at this really simply, if we have the product, meaning multiplying 2 powers that have the same base, well, if I ever forget these rules, I just think about what it means. Doesn't x squared mean x times x? And x cubed means x times x times x. So just by counting, I can see that that really means x to the 5th power. Alright, I'd like you to go over here, and I'd like you to try to simplify these 3. So 7 to the 8th times 7 to the 4th is going to be 7 to the 12th. One of the most common errors is kids will want to try to do something with the bases, like do 7 times 7 and get 49. But if you go back to the previous example, this really means 7 times itself 8 times. And then 7 times itself 4 times. So if you think about it this way, it's pretty easy to see that that comes out to be 7 to the 12th. Okay. So this one, the base would stay the same. We would add the exponents. Negative 3 plus 5 is 2. And the last one the base stays the same of x, but when you add the exponents, -1 plus -3 plus -4 is -8. But then going back to the beginning of the lesson, this is not in an appropriate form to leave your answer. Because it has a negative exponent, we have to write it as 1 over x to the 8th. Okay? Alright, the next property is called the power of a power property. So when you have a power that's being raised to another power, what you do is when you have a power of a power, you multiply those two exponents together. The base stays the same. So I often say when you raise a power to a power, you multiply the powers. So here, when you raise 3 to the 6th to the 0th power, it becomes 3 to the 6 times 0 power. And we learned yesterday that anything to the 0th power is 1. Okay. So here, when you have a power being raised to a power, you multiply the power. So this would be x to the -8th, which again has to be reduced to 1 over x to the 8th. And the last one down here, raise a power to a power, you multiply the powers, you get x to the 12th. Okay, I'd like you to write down this example. I'd like you to pause the video and get a solution, and when you're done, restart the video and we'll go on, and I will check this in class on Thursday. Okay, the last property is called the power of a product. So this means we're taking a power of a product, meaning two things are being multiplied together in parentheses, and it's all being raised to a power. Well, it's kind of similar to the distributive property. This nth power has to be applied to every term, every part of this product. So it becomes a to the nth times b to the nth. And you've probably used this product or this property a little bit without realizing it, but we've talked a lot about something like this. This really means that 4 is being cubed and p is being cubed. Now this technically would not be simplified because this coefficient, there's some work to be done, so you would figure out what 4 cubed is. I can't remember what that is. I want to say 256, but I can't remember. And the last one, this one would mean we have to raise -5 to the 2nd power. Then we have to raise p squared to the 2nd power. So notice that within this problem, not only are we raising each part of the product to the 2nd power, but we also end up having a power being raised to a power. So to simplify this, -5 times -5 is 25, and p to the 2nd power squared is p to the 4th. Okay, so let's look at this example. Take a minute to write this down. If you need to pause the video to get that written, please do that. I'll give you a little bit of a hint. Notice that each part of this product all has to be raised to the 4th power. So this is going to become x squared to the 4th times y cubed to the 4th times, we're going to do the same thing here. Everything in parentheses has to be raised to the -4th power. So x squared to the -4th and y to the -4th. Okay, because this one's a little more complicated, I'll go on and we'll finish this. So this becomes, move this out of the way. This is going to become x to the 8th, y to the 12th, times x to the -8th, y to the -4th. Because when you raise a power to a power, you multiply those powers. So 2 times 4 is 8. 3 times 4 is 12, and so forth. Now this would not be considered simplified because do you see the bases are repeated? So there's something more we can do to simplify x to the 8th times x to the negative 8th. And we're going to apply that same property we did earlier. X to the 8th times x to the negative 8th is x to the, we add the exponents, so 8 plus negative 8. So that becomes x to the 0th power. And when we do the same thing with the y's, when we do 12 plus negative 4, we get 8. And now we can simplify this because anything to the 0th power is 1. So we get y to the 8th. Okay, that's all for the notes. And this is what you need to do to kind of follow up and be ready for class tomorrow. So I'd like you to do all of these examples. So if you need to pause that to get those down, I expect those to be completed, and we will see you tomorrow. Have a good night.